Okay, oxalic acid is our other organic acid we need to be looking at. It's diprotic, which means that those two hydrogens are both going to be lost. It's actually two carboxylic acids back to back. So the concentration of oxalic acid was determined, so that's our unknown, with a standard sodium hydroxide solution, so that's the one we know the concentration of using phenolphthalein indicator. A 20 ml aliquot of oxalic acid. So our oxalic acid is the aliquot, so it's down here. So our C2H2O4 is down in there, and our sodium hydroxide is up here. Be really careful here. This is starting to get a little bit trickier because we've got our volume and our concentration in the one sentence. So it's really tempting to think that that 20 mils and that concentration go together, but they don't. So it's a 20 ml aliquot of the acid, and it was titrated with sodium hydroxide. That's our concentration. And then we need to work out the volume that we've added here. So this is getting a little bit more complicated. The volume, we actually have to find the average titer before we can work out our known. All right, so we need a reaction. You can't do anything without a reaction. So this is our acid, oxalic acid, acid plus the base. So this is a classic one, makes a salt and water. So you can see that the actual reaction is between both of the hydrogens on here, going with the hydroxide to make the water. And so the C2O4, if it's lost two H pluses, it becomes 2 minus. So you need, each sodium has 1 plus, so you're going to need 2 sodiums. So because you need to be able to balance that formula correctly in order to know that I need 2 of these sodium hydroxides. And then that way I'll have 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, so 4 hydrogens altogether, so you need 4 water molecules. Okay, so this is called sodium oxalate, probably. Don't forget your states, obviously. So, there's no guiding questions, so you need to know that you're going from your known. So you have to work out your average titer first. So make sure you look at your numbers, your titers. The one that you pick, the 3 that you pick, have to be within 0.1. So which one did we leave off? 22.06. Okay. So this is from 0.00 to 0.08. So the biggest jump is 0.08, which is less than 0.1. So they have to be within 0.1 mils of each other, from the highest to the lowest. Alright, so you add them all up, divide them by 3, and we get our average volume. Turn it into litres, put it in your equation to work out the known. So it's the number of moles of sodium hydroxide that's been added. This is your known over here, sodium hydroxide being added. So now you're using a concentration up there and your titer to work out the number of moles that's been added. Then you use your ratio to work out the number of moles of the unknown. So it's a 1 to 2. So make sure you put what you want on the top. So what you want is the acid. It's a 1. Acid is 1. And what you want is, what you've got is the sodium hydroxide. So it's half the number of moles of this. So you take this over the other side and multiply it. Half of the 0.026, which is 0.013, so we're nearly there. So then we can just work out the concentration, which is the volume that you had at the beginning, the 20 mils of your oxalic acid, and the moles that we've worked out. Okay, make sure you've got your correct number of significant figures. So I've got 3 because this concentration had 3, and make sure you put your units, concentration, moles per litre. Okay, getting faster.